So sketch the curve y equals x times by tangent x. So this function involving trig functions, okay, so we have to pay attention to it, okay. Alright, it told us the domain of the function is from negative pi half to what? Pi half. So do we have to figure out the domain of the function, yes or no? No. It's given. Another thing that I want us to pay attention is, do you know how to graph the function y equals tangent x? Do you know the graph for tangent x? It's periodic functions, right? Yeah, yes, you're right. However, in this question, we only talk about when x varies between negative pi half to pi half, right? So tangent function looks like this, right? So this is tangent function, y equals tangent x. Okay, when x is between negative pi halves to pi halves. Am I right? Okay, and then we have to know some key values when x equals pi fourths. What is the value for tangent pi fourths? Do you know? 1. Okay, yeah. When x equals negative pi fourths, y equals what? Negative 1, right? So negative pi fourths, y equals negative 1. Okay, and what do you think about the tangent function? Is it the odd function, even function? Graph is symmetric with respect to origin, so tangent function itself is what? Odd. You're right. Is odd. It is an odd function itself, okay? Tangent x. So I need you to know at least this, okay? However, we're not going to graph y equals tangent. We're going to graph y equals what? X times by what? Tangent x. Okay? So first, the main is this. What is the second step? You guys tell me, please. Find what? Intercepts, right? Find x and the y intercepts. Let x equals 0. y equals what? 0 times by tangent 0, 0, right? So y will be 0. This order pair 0, 0 is what? What intercept? Y intercept, okay? And let y equals 0 means x times by tangent of x equals 0. So for what? So for x. X times the tangent of x equals 0. Where x will make x times the tangent x equals 0. Can we choose when x is positive? If x is positive, tangent x will be what? Positive. Positive times positive will be positive.
So that would be 0?
Yes. If x is less than 0, tangent x will be less than 0, so negative times negative give us positive. So only when x equals what? 0, it will make this equation satisfies, okay? So that means 0, 0 is what? X-intercept. Alright, so origin will be both of the x and the y-intercepts. You guys
How do you know y-intercept again?
What?
How do you know y-intercept?
That x equals 0.
Right.
And then,
Okay, that's fine.
yeah. Alright, step 3. What is step 3? Can you please tell me step 3? Symmetry, right? Symmetry. Alright, so if y equals x times tangent x, this is our f of x. So let's check f of negative x. F of negative x means we're going to replace every x by what? Negative x. You agree with this? Okay. So, negative x is still negative x. What is tangent of negative x? Tangent function itself is odd. So tangent of negative x equals what? Negative tangent of what? X, right? And negative cancel out. So this gives us x times by tangent of x. What is x times tangent of x? Is it exactly f of x? Yes. Ooh, f of negative x equals f of x is satisfied what? This function is even or odd? Even. Okay, so f is an even function. Okay, so the graph is what? Symmetric with respect to what axis? Y-axis. Okay, so the graph of the function is symmetric with respect to y-axis. Everybody? All right, step 4. Asymptotes, right? X times tangent of x. Do we have a fraction here? No. So that means when x is between negative pi over 2 and pi over 2, there's no vertical asymptote between negative pi over 2 to pi over 2. However, this so it's two vertical lines, x equals negative pi over 2 and x equals pi over 2 may be our vertical asymptotes. However, we talk about when x between negative pi over 2 to pi over 2. In between, there's no vertical what? Asymptotes. Okay. However, it says x is between negative pi over 2 to pi over 2, right? So I would say, and since when x goes to pi over 2, tangent of x goes to what? Infinity, right? So infinity times by a constant pi over 2 is infinity. So I would say, if we write down the vertical asymptotes, it's going to be what? Negative pi over 2 and then positive pi over 2. Okay, so vertical asymptotes are these two. But there's no vertical asymptote in between because there's no denominator here. Okay, there's no in between. Okay, it says these two are the vertical asymptotes because when x goes to either negative pi over 2 from the right, or when x goes to pi over 2 from the left, our graph will goes to positive infinity. Okay, so let's remember the definition for vertical asymptotes, right? So when x, because this is explanation, okay, because y goes to positive infinity as x goes to negative pi over 2. Okay, and this one, why this is a vertical asymptote? Because y also goes to infinity as what? X goes to positive pi over 2. So that's the reason why they are the vertical asymptotes. Do you have any horizontal asymptotes? When x goes to infinity, let's check. And also x goes to negative infinity, let's check x tangent times tangent x. When x goes to infinity, x goes to infinity, right? How about tangent x? Infinity. So infinity times infinity is what? Right? How about when x goes to negative infinity? Tangent of negative infinity, I shouldn't say tangent of infinity equals infinity because this tangent of x is what? It is bounded, right? It's periodically. Here, we're not checking this, sorry. Because the domain of the function is between negative pi over 2 to pi over 2. So we will not talk about when x goes to infinity, when negative infinity, what is the shape of the graph, right? So I would say we're not checking this. So there's no horizontal asymptotes, okay? So no horizontal asymptotes, because horizontal asymptotes we have to check when x goes to infinity or negative infinity. But the domain is also restrict us that, the graph must be bounded between, an open interval. So that's why there's no horizontal asymptotes. Does it make sense, everyone? Okay? Alright, so these are the first 4 steps. What is step 5? Graph increasing, decreasing, right? So what do we do? derivative, right? Find derivative. If y equals x times by tangent x, y prime should be what? By using the product rule, difference x give us tangent x. Then plus x times by, what is the derivative for tangent x? Anyone knows? Is it secant x squared? Yeah? Okay? So this is a y prime. And then there's no denominator. So we're going to let y prime equals 0 and see what kind of x we can get. So that will be the critical point number for us. So if y prime equals 0, this thing will be what? 0, okay? That means tangent of x plus x times secant of x squared must be 0. What are x values between negative pi half to pi half will make this equal 0? See, when x is positive, tangent x is positive, positive times positive will be positive. No way. When x is negative, tangent will be negative. This will be negative times by positive is negative. Negative plus negative will be negative. So only when x equals what? 0. Yes, you're right. This what implies x equals what? 0. And x equals 0 is our critical number, right? Right. So is a critical number, we're going to divide the root number line by when x equals 0, right? Then on the two intervals, key numbers, right? Key numbers. This interval, let's choose negative 1. This interval, let's choose 1. How about the signs for y prime? When x is less than 0, when x equals negative 1, tangent of negative number is negative. Negative times by positive is negative. Negative plus negative give us what? Negative, right? X equals 1, positive, positive, positive. Oh, sorry. That means the graph will be decreasing on this interval and will be increasing on this interval, right? So we'll say y is decreasing negative infinity to 0. Yeah, I will give you questions on the test about how to graph a function, and you have to do all of these steps in order to graph, okay? To sketch the graph.
As negative infinity, or do we write it as negative pi over 2?
Oh yeah, you're right. Pi over 2. Sorry, my bad. Pi over 2, you're right. So negative pi over 2 is here. So I would say this open interval, right? You're right. Pi half positive pi over 2. Oh. Thanks for reminding me about that. Yeah, so y is decreasing, right? Because y prime is negative. Negative pi over 2 to 0. And y is increasing on 0 to what? Pi over 2. Everybody? Alright, very good. So, because y and our function is decreasing, and also increasing, well, we have a local minimum or local maximum. Decreasing, increase, we'll have a local minimum. Do you see that? Yes. So step 6, y of 0, or f of 0. 0 times by tangent of 0 equals 0 is what? A local what? Minimum value, okay? X equals 0, y equals 0 is a local minimum. Everybody see that? Alright, step 7. concavity. Second order derivative, we do it from here, okay? We differentiate the y prime, okay, y prime. So, y prime, you have that, okay? Derivative of tangent x gives us what? Secant x squared. Differentiate this, product rule. Differentiate x 1 times by secant x squared plus keep the x. How to differentiate the secant x squared? Chain rule and the power rule, right? It should be 2 times by secant x and times by the derivative of secant x. What is derivative of secant x? Tangent times secant. Okay? Alright, so let's see. Secant x squared plus secant x squared 2 secant x squared plus 2 secant x squared times by x times by tangent x, right? Times by x times by tangent of x. Any common factor? One plus x times by tangent of x. You guys? No denominator, so the only case is we let y prime prime equal 0 and solve for x. That will divide the real number line. So if y prime prime equals 0, it means what? Either this factor equals 0 or this factor equals 0, right? So secant of x squared equals 0 well implies what? Or let's see. Okay, so let's analyze this, okay? Secant x squared is always greater than or equal 0, right? Positive or 0. How about 1 plus x times tangent of x? X function, y equals x, this function is odd. Tangent of x is also odd. Odd times odd, even, right? Just now we checked. X times by tangent of x is odd, is even, okay, is even. So, means, if x is positive, x times tangent of x positive, plus 1, positive. If x is less than 0, tangent x will be less than 0. Negative times negative is also what? Positive. Positive plus 1 is always positive. And the secant of x squared is always what? Greater than or equals what? 0, right? So we will secant x equals 0. Secant of x equals what? 1 over cosine, right? So it will not be 0, okay? It will not be equal 0 because this is a 1, okay? So that means secant of x squared is also positive. So there will be no case for us to let y prime prime equal 0 because y prime prime is always what? Positive. No matter x is greater than 0 or less than 0, y prime prime is always positive. So that means on the entire domain from negative pi over 2 to pi over 2, this graph is what? Concave what? Upward. Okay? So y is concave upward on the entire interval from negative pi over 2 to what? Pi over 2. Okay? Alright? And we know, from negative pi over 2 to 0, graph is decreasing. From 0 to pi over 2, graph is what? Increasing. And the entirety on the entire, domain, graph is concave upward. Right? Because y prime is always positive. Okay, always positive. Alright, are we ready to graph? Alright, so, okay, so we're going to have a 0 in the middle, and then we have a pi over 2. We're also going to have a negative pi over 2 on the left, and then pi over 2. What is the value for pi over 2? 3.14, about 3.14, blah, blah. Divided by 2 give us the 1.7 something, right? And this is negative 1.7 something, okay? And then, so 1 should be here, 1 and 2, negative 1, negative 2, we don't know, okay? We'll see, okay? We'll see. Alright, let's check. Domain. Negative pi over 2 to pi over 2, in between, okay? Our graph will be in between. Step 2. What is intercept? What intercepts? Origin. Our graph will pass through this point, origin. Step 2, f is even, so graph is what? Symmetric with respect to what? Y-axis. Okay? But we don't know how, okay? Vertical asymptotes, two of them. No horizontal asymptotes, okay? So let's do this. Vertical asymptotes, x equals pi over 2, x equals what? Negative pi over 2, right? Alright, so, and then graph will be what? Pass through this point, and will be symmetric with respect to y-axis, okay? Oh no! Step 5 tells us, from negative pi over 2 to 0, graph is decreasing. From 0 to pi over 2, graph is increasing, and has a local minimum at the origin. Also, the graph is concave upward, decreasing until this point, increasing, and give us a local minimum here, right? And then it's going to be symmetric with respect to the y-axis and concave upward. Can you tell the shape of the graph? Looks like that. However, we want to get some key point to help us, right? So I would say, let's still get some key values. Okay, y equals x times by tangent of x. So how about when x equals negative pi over 4? X is negative pi over 4 times by tangent of negative pi over 4. It gives us what? Negative pi over 4. What is tangent of negative pi over 4? Just now we did it, right? Negative 1. So eventually give us what? Positive pi over 4. You see that? X equals negative pi over 4. Y equals what? Pi over 4. So negative pi over 4. Where is pi over 4? Pi is 3.14 divided by 4. Negative slightly less than 1, right? So I will say this is positive pi over 4. Oh, point is here. How about when x equals pi over 4? Pi over 4 times tangent of pi over 4. What is it? Pi 4 times by 1. Pi over 4. Oh, x equals pi over 4, y equals pi over 4. Okay.
Since we know that it's symmetric to the y-axis, you could just assume that the second point goes there, right?
Yeah. Briefly, draw the picture. See? Decreasing from negative pi over 2 to 0, increasing from 0 to pi over 2, concave upward, symmetric with respect to y-axis, and satisfy all of those. So, briefly picture for y equals x times by tangent of x. Everybody?